Hey guys, do you need extra help with your projects? Have simple questions you need answered? Maybe you just want to see my content a little bit sooner. I have tiers for all this on my Patreon, link in the description. Hello everybody and welcome to the basics of artificial intelligence in the Unreal Engine. This guide is using engine 5.1.1. Most engines will work even older or newer than this, but remember that you might have slight variance in the way that your code works and potential naming schemes. This guide also is going to assume you have a base level understanding of Unreal Engine. If you do not, in the description, I will include a link to the basics of the Unreal Engine. Start there, then move over to here. Let's start with a really quick visual diagram because there's a couple parts that have to come together to make AI work. And if we were to just jump into connecting those parts, it could be very confusing as to why each of them needs to exist and exactly what they're doing. So you can think of AI as two main parts. You have the pawn, which is the body, which contains things like the collision, the character movement, the animation blueprints, the 3D model, everything that makes the character the character. And then you have the behavior tree, which is how the AI is going to make decisions. And it's going to make those decisions using a blackboard that contains variables. A really simple way to think about how the decisions are made with variables would be, we're close enough to a door? Yes. The door is locked? No. Okay, go through the door. Very basic example, but again, we have the pawn and the tree, the body and the brain. You might already have a character that you want to use, but I don't, so we're going to very quickly make one. I'm just going to make a folder. I'm going to call it AI. We're going to open that up. We are going to create a blueprint class. Now, this is where it kind of seems a little confusing because I labeled it a pawn, and it is a pawn. However, in this case, we're going to select character because a character is a pawn with additional things assumed like character movement. I'm just going to call this BP underscore AI tutorial. I'm now going to open that up. So to relate this back to the diagram, this is a pawn, but because it's a character, it does a couple things for us. It gives us the character movement, which you remember we needed. We have a mesh here that we can put in anything we want, and our collision, which is the capsule. So you might already have a static, or not a static mesh, a mesh you want to use. I'm just gonna be using the default Unreal Engine mannequin. I'm gonna be using Quinn just because I like the futuristic, nice, sleek model. Get them into position, then I'm gonna rotate them because it always starts slightly rotated incorrectly for some reason. Also not a huge deal, but I always like to make sure these numbers aren't 0.99999. I think it's probably just a slight performance boost to do that, even if it's like microseconds. Then luckily we should already have an animation class for the mannequin, which is the ABP underscore Quinn. So now they have their animations. We have an animation, we have a skeletal mesh, we have character movement, and we're good to go. We need to hit save and compile, and believe it or not, for right now, that's all we need. The pawn is set up and ready to go. There's additional things we can add later if we want to add certain interactions and features, but right now, the pawn is ready for use. So we have our body, but now we need a brain, otherwise we're not really going to be able to do anything. Now this is actually a two-step process because for some reason they don't immediately come combined. I'm sure there's a reason for it, I'm not sure what it is. However, what we're gonna do is we're gonna right click, we're gonna go to artificial intelligence, and we're gonna create that behavior tree because as you remember, this is our brain. So I'm just gonna call this BT AI tutorial. Now what I like to do is make sure I have a consistent naming convention between the pawn and the brain. I'm sure there's niche scenarios where you won't do that, but that's why I do what I do. However, as I said, this is a two-step process. We also need to go to the artificial intelligence and create the blackboard. This is something I've already mentioned, but I'm gonna go ahead and name this BB, and again, AI tutorial. The blackboard and the behavior tree are kind of one and the same. I like to think of the tree though as the more important of the two because the blackboard is going to hold information, variables for us, whereas the tree is where we're actually going to write the code to make decisions and understand what it is we need to be doing. I'm going to go ahead and open up the behavior tree. As you can see, they are kind of one and the same, because if we look at the top right, you'll see we have behavior tree and we also have Blackboard. Now, if there's only one Blackboard present, it should already be set up by default. However, you see this little drop down menu here that says behavior tree. If we open this, you'll see that the Blackboard asset can be selected. If yours isn't selected here, make sure to have it selected. Remember, the tree is going to use this as a data bank for variable information to make decisions. Is the door open? No. Do I need to go through? Yes. Those are just Booleans. Now let's go over the basics of a behavior tree. You'll see we have the root, and honestly, behavior trees are upside down. The root is the top, and then we grow down. See, I can drag out of this and you'll see we have a selector, a sequence, and a simple parallel. Now, these are a little confusing at first, so what we're gonna do is we're simply gonna click on the word sequence. Now, what is happening here? Basically, the root is where the code starts, and the only place it can go right now is it's going to drop down into the sequence. A sequence is essentially saying, I'm going to start on the left, do everything in order that's connected to me until I'm all the way to the right. For example, I can pull out of this and you'll see we have one called tasks. These are the ones that are by default in the engine. We're going to probably be making our own in conjunction with the ones that are in the engine, but we're gonna go ahead and just, mess with a couple of these to give you an example. We'll go ahead and hit move to, which right now it won't do anything, and I'll explain why in a second. And this side, we will then do wait. So since it's a sequence, it's gonna start on the left-hand side. It's gonna say, hey, move to, and right now you'll see that the variable, which again, if we head to the Blackboard, this is our database of variables. Look, self actor, this is one of the variables in there. So it's going to move to self actor, as in itself, so it wouldn't actually do anything. But then, once this is complete, it will move to the right. Now it's going to wait for 5 seconds. But what happens after we wait? Well, since there's nothing else here, we would move back to the root and go back down the tree. We would hit the sequence, go to the move to, wait, and it would do this endlessly. However, moving to self actor is boring because it'll never actually move. So let's talk about how we get a random point around us, move to that point, tell the tree that we've successfully done it, and then choose another location and move to the new location. Essentially move around randomly. Well, since we can only move to variables that are in our Blackboard, so you'll see Blackboard key self actor, it's the only option. We need to create a variable, so we'll hit new key, and in this case we want a vector because we want a location in 3D space. That's what vectors are. I'm gonna name this target location. It's good to be generic with your naming convention in most cases, and we will explain why as we continue. Now that we have target location selected, we're gonna head back to our behavior tree. We're gonna click on this, and look, Blackboard key. I can now change this from self actor to target location. That's great, but we don't have a target location. We have a variable, but it's never being updated. It's never being set. So what would it do? Well, in its current state, it would probably move to 0, 0, 0 as that's the default value for a vector. But we want to update that. So we need to create a task that the AI is going to do that will update that variable for us. Now, remember, move to is a task, but if I go into here and look, you'll see that there's nothing here about getting a location. So we need to create our own custom task. At the top, you'll see we can actually click on new task. Then it wants us to choose a location. So the default location is it's going to open up where the behavior tree is located. I like to just create a new folder and call it tasks. And then you can go ahead and create a naming convention that is very generic for tasks, because even though these tasks will be developed for this specific AI, some tasks can be used for everything. Like, for example, getting a random location is not something that is going to be specific to this one AI. Getting a random location could be used with several different types of AI. So generic task naming tends to actually be the best here. I like to just leave the default naming convention of BT task, which is a behavior tree task. I like to leave the underscore, and I'm gonna put get random location. And we're just gonna hit save. That's gonna immediately open up the task, and it looks a lot like a normal blueprint. And that's because it is a lot like a normal blueprint. There's gonna be a weird cut here. I have to go to work. I'll be back soon. Okay, it's several hours later and I'm back and we are exactly in the task, so let's get started. As I said previously, this is a lot like a normal blueprint, and if you remember, like a normal blueprint, you need an event, something to happen in order to fire some code. Well, for AI, it's actually something called an execute. So if you type in the word execute, you'll see that we have event receive execute AI. This is essentially whenever the behavior tree comes across this task, that is what calls this node. You'll see we even get some basic information like the owner controller and the pawn. However, all we want to do is get a random location and move to it. In order to do that, I'm going to drag out of our execute pin here, and I'm going to type in get random location and navigatable radius. Grab both, press Q to straighten up that line. Now, why does it say get random location in navigatable radius? Well, you'll see in just a little bit, we're going to use something that tells the AI where it's capable of moving. And all this node is saying is, hey, I'm gonna get an area specifically in the areas that I can move. If we just pull out of the controlled pawn and type in get actor location, then we can take the return value, and that will now be the origin point for our random location and navigational radius. Now we'll set a radius. So we want this to stay within like 500 units of the location of the actor. This is when things are gonna get a little strange. We need to update in our Blackboard this target location variable. However, we need to somehow access it, otherwise we can't update it, right? Well, yes and no. Luckily, tasks are a bit dynamic. What do I mean by that? Well, I'll show you. Out of the random location, I'm going to type in set Blackboard, and you'll see that we have one as vector. Normally, you would be able to see booleans, I'm blanking, integers, floats, all of them, but this is specifically a vector and it's context sensitive. So here is the vector. Now you'll see that we need a key. If we pull out of this and promote to variable, you'll see that we got a new variable on this left-hand side, and I'm actually going to update the name of that to target location. So let's recap. We receive the execute from the behavior tree. We get our location. We look out within 500 units and we say, get a random location somewhere in that area. We get one, and then we save it as a Blackboard value as a vector. I named it target location. You do not have to name it that. These do, basically the reason I'm telling you that is this target location and this target location do not have to be named the same. I do for convenience sake, but just so you know, that's not required. Now, there's one last thing we have to do that you wouldn't normally have to do in a regular blueprint, but this is a task for an AI. So here we executed the task. Now we need to pull out and type in finish execute. And you'll see that there's a success here. We need to check this so it's successful. If it isn't successful, the behavior tree will consider the task incomplete and it will never pass the task because it will never get past this successful Boolean. So just remember, a task has a start and an end. Now, let's talk about what we did right here, setting Blackboard value as vector. Let's head back to our behavior tree and see how we can actually use that node. Now, we're gonna pull out and we're gonna see our task in the list now. BT task get random location. I'm gonna click on that and you'll see that our task now appears. On the right-hand side, you'll see that I have made a classic mistake. In order for the variable that we created to show up here, we need to make sure that it is public by opening up this eyeball. So save and compile with the eyeball open, and you'll note that now on the right-hand side, you'll see our variable target location is now present. And look, we can now select a variable that's in the Blackboard that is updating. Well, we're updating the target location. Again, these names do not have to line up. I do it for convenience sake. So now when it runs that task, when it comes across set Blackboard value as vector, it's going to set that as target location right here in our Blackboard. So let's see what's going on here. We get a random location and update our variable target location. We move to target location, wait 5 seconds. Then we're gonna go back to the root because we're completely done with the sequence and there's nothing else to do. We're gonna go back to the sequence, get another random location, move to that, and wait 5 seconds. So how do we get the brain into the AI? Well, we need one more file for that. And it's very simple, so don't panic. We're gonna right click, we're gonna go to Blueprint Class. And now what we need to do is we need to open up all classes, type in AI, and you'll see one is called AI Controller. Go ahead and hit select. I'm gonna name mine AIC for AI Controller _ AI tutorial to be consistent. Let's go ahead and open our new AI controller. And what we're gonna do is basically the AI controller is how we choose what Blackboard we want the pawn to run. So what we're gonna do is out of the event begin play, we're gonna pull out, or did I say Blackboard, I meant behavior tree. And we're gonna type in run behavior tree just like that. Target will be self, grab both, press Q to straighten out the line, and we will select the only behavior tree that should be here, which is ours, save, compile. And now we'll head back to our pawn and set it up so that way it uses the correct brain. Click on BP AI tutorial here at the top. On the right-hand side in the search, type in AI, and you'll see I already set mine up from a previous take. However, yours is going to look more like this, placed in world and AI controller like that. What you want to do is switch placed in world to placed in world or spawned, and then the AI controller class needs to be the new AI controller that we just created. Let's go over the 4 steps real quick. Our AI controller just chooses the behavior tree. Our behavior tree runs a task to get a random location, updates the Blackboard with that location. We move to it, we wait 5 seconds. That's it. The pawn already has the correct controller already selected and it's all hooked together and nice and pretty. There's one last thing we need to do. In our world, at the top here, you're gonna click on quickly add to project. You're gonna go down to volumes, and the very first one will be a nav mesh bounds volume. Now, it just kind of looks like a cube and nothing's going on, but if you press if you press P on the keyboard, you'll notice that inside that volume, it should turn green. Mine didn't turn anything, which is a bit strange. However, green indicates that the AI knows that it's allowed to go in that location. Instead of scaling this thing up, I highly recommend just scrolling down until you see brush settings, and let's just increase the brush settings to like 2000 in each direction besides Z. We'll just keep it on this base level. And essentially, everything that's green now is somewhere that the AI knows that it's able to go to. So if we pull in our AI that we've created and or the pawn that has the AI controller attached to it, when we hit play, now the behavior tree is going to make that pawn every 5 seconds, choose a random location within 500 units, and then move to that spot. Wait 5 seconds, do it again. As you can see, the animation blueprint isn't quite working. It's never actually running, but that's not the important part here. The important part is that the AI behavior tree is functioning how it's supposed to. I'm gonna hit the Windows key so that way I can move over to the behavior tree and you can actually see how it's making decisions. It's waiting 5 seconds, goes back to the beginning of the sequence, does the move to waits 5 seconds. So that's the super basics to AI. If you guys are enjoying this series and want me to keep expanding on AI and let you guys learn more about it, just let me know by leaving a like and a comment. I know I'm gonna at least do one more of these where we have the AI actually make a decision based on a certain set of variables, so that way we can continue to develop the basics of the AI. But for now, like, comment, and subscribe, and I'll see you guys in the next episode.